In this video, we're going to solve algebraic fractions. So we're basically solving equations. Now you might want to watch simplifying algebraic fractions first, that video, because it might actually help you to understand some of these processes. So I'll start with a basic fraction, 3 over 5x equals 2. So we're trying to solve this. So what I'm going to do is notice that how the whole of the left-hand side is divided by 5x. So we do the inverse. So in other words, I'm going to multiply by 5x. So I'll show my working. Multiply both sides by 5x leaves 3 on the left and 10x on the right. Finally, I'm going to divide through by 10. So that gives me 3 over 10 equals x. It doesn't matter that x is on the right. If you're not happy with that, the two equal each other. So you can just rearrange it and say, well, x actually equals 3 over 10. Look at a little different scenario now where I've got fractions on both sides. Now with this particular thing, what I'm actually going to do is this whole side is divided by x. So if I'm going to inverse that, I'm going to multiply both sides by x. So that will come up here. And then this fraction down here has a 5 as the denominator, so I'm actually going to multiply 5, and that's going to go up here, kind of like cross multiplication. So that becomes 3 times 5 is 15, and 2 times x is 2x. Now, in order to solve, let's put the working down the right hand side to say that I've multiplied through by x and I've multiplied by 5 at the same time. At this point, to get x, I need to divide by 2 to isolate it. So x becomes 15 over 2. You'll notice how I've switched sides just so it looks neater, and that's perfectly okay. Alright, next example. Let's look at a trickier one. Okay, so here we go, and you'll notice I've got two fractions on the left hand side. Easiest thing to do here is to just find equivalent fractions with the same denominator so that you can bring those two terms together, and then it makes it much easier to solve the overall equation. So I'm actually going to find equivalent fractions. So I'm actually just going to simplify here. So let's get 15 as the denominator on the bottom here. So that means multiplying this fraction by 5 and this fraction by 3. So that will give me 5x over 15, take away 6x over 15. And of course, the left-hand side can now be added together, collecting the like terms, giving me a negative x over 15 equals minus 1 on the right. Now it's a simple problem to solve. So to undo this, I'm actually just going to do the inverse, which is times by 15. What actually happens is on the left, you've got minus x equals minus 15 on the right. We don't want to have minus x, so I'm actually going to multiply the whole thing, both left and right side, by minus 1 or negative 1, which gives you a positive solution. So therefore x equals 15. Okay, I'll just do a little bit more of a complicated one, building up slowly. Okay, this one here has a denominator of 6 and this has a denominator of 3, all on the left hand side. So I want to try and ideally combine those fractions. What I also spot is the numerator of this part can pull out a factor of 2. So let's do that first. If I pull out a factor of 2, I'm left with that. Oops, sorry, hang on. Rewrite that, made a little error. Sorry, it's 2 minus x over 6. Now, what I can actually do here is I can now cancel, because both of these go into 2. So that becomes 1 over 3, hence meaning I'm going to have the same denominator of both these fractions. So let's just write that, x over 3 minus 2, bracket 2 minus x over 3 equals minus 4. Now, when I simplify the two fractions together on the left, collect together like terms, I notice that this here, oh, hang on, there's an error. There we go, that should be a 1, so therefore we don't need to write anything. You'll notice that this here is take away all of this, which when you multiply that by negative 1, you get minus 2 plus x. So when I simplify this, I've got x minus 2 plus x gives me a total of 2x minus 2 on the top there, over 3 equals minus 4 on the right. So now I can solve it like a regular equation. I'm going to multiply, because the whole of the left-hand side is now divided by 3, I'm going to multiply by 3. That's the inverse, leaving me with 2x minus 2 equals negative 12. Finally, I'm going to add 2 to both sides, and that will give me 2x equals minus 10. And then I'm going to divide through by 2 to solve and isolate x, giving me x equals negative 5. Alright, next one, a little bit trickier. So this one, I'm now going to see that the left-hand side is all divided by y minus 1. I'm going to treat that as though it's all one term, and I'm going to multiply the whole of the left and the right-hand side by y minus 1. Now, by doing that, I'm actually going to have an equation where I've got y's on both sides. So I can write it like that to begin with and then expand the bracket on the right. So I'll do that. So let's expand. On the left, I've still got 3y plus 1, and on the right, I've got 2y minus 2. Now I've got y's on both sides, so I'm just going to look for the larger one, the smaller y term, which is the 2y, and I'm going to subtract 2y from both sides, leaving me with y plus 1 on the left, and just negative 2 on the right. Then I'm going to deal with this plus 1 by subtracting 1 from both sides, leaving me with y on the left, minus 1, take 1 is minus 3. And that's the answer. Let's just do the final example, which is very hard. It's a complex fraction. Okay, so as you can see here, I've got fractions here and here on the left-hand side. Before I can do anything, I want to get the denominators the same, so I'm going to just find equivalent fractions. So in order to do that, I'm going to multiply this whole fraction by 2 and this whole fraction by 3. So doing that gives me 2 bracket 2y plus, plus 1, to be a mistake, over 6. Minus, and multiply all this by 3 bracket y minus 2 over 6 equals 5. And now I'm going to expand the brackets, so I get 4y plus 2 over 6 minus 3y minus 6 over 6. Okay, equals 5. Now I can got the same denominator, so I can collect the brackets. Now I just need to be careful here. This is minus 3, and obviously minus 3y, that will become a plus 6 there. Alright, collect the like terms. 4y minus 3y is y, plus 2 plus 6 is plus 8, all divided by 6 equals 5. Now I'm going to multiply both sides through by 6. We're working over there on the right. I haven't drawn a line, but never mind. So y plus 8 equals 30. Then I'm going to subtract 8 from both sides to leave y equals 22.